Hello children. So today we are starting with continuity and differentiability, and regarding this continuity we had already discussed in our 11th standard, and I had explained something about this continuity also. I'll just briefly tell you about what was the limit and when is it called as existence of a limit, and when is it continuous, and what is the definition of continuous. And the more we talk about this continuity and differentiability, the more it is of confusion. So I'll tell you in a very simple way, and I'll tell you what is the meaning of continuous function along with the graph. Understand in a very simple way, and we'll run off with the problems. After certain problems, certain number of problems, I'll get back to the algebra of functions, and I'll tell you more theory of this, because the theory of this is very important for JEE questions, for objectives, and to understand the meaning of the functions. So let us go to something, the basics of this limit. See, we say limit exists. Now this is a few part, initially whatever I say, it is from your 11th standard what we have already learned. So it's only a recall. Suppose I take a graph, x-axis, y-axis, origin, and we have a graph like this. See, this is said to be a continuous function. There is no break in the graph, so it is a continuous function. And now suppose I give you a break here, this particular point, I will not get to know what is the value of that function when I put x is equal to a. So I have some function limit of f of x as when x is equal to a, that is called as f of a. This point is f of a, and I'm not getting the answer at that particular point. So what do? I will start taking the tendency values towards a. So I'll start taking few values towards a like this, and when I take that range of small epsilon values less than a, then we call that as the left hand range. Okay, I will directly write it as left hand limit. When I apply limit for that and try to find out what are the answers just behind a, that is a minus. So we say left hand limit as limit of f of x as x tends to a minus. A minus does not mean negative a. It means that it is a number, it's a few smaller values lesser than a. So a minus, which means this is left hand limit. Similarly, if I take a few values of the same kind on right hand side, then that is said to be right hand limit. How do we indicate it? We indicate it as limit of f of x as x tends to a plus. And suppose both left hand limit and right hand limit are giving you a certain value, say number 3. This also fetches you the number 3, the value 3. This also fetches you the number 3. Then not exactly 3, also maybe 3 point, maybe here it is 2.999. and maybe this side it is 3.001, then I will conclude that at that particular point f of a also it should have been the limit value as 3. So we say f of a is equal to this limit value L. So this is we call it as limit value. It's called as limit value. So limit of f of x as x tends to a minus, if it is equal to limit of f of x as x tends to a plus, then so let me write if LHL is equal to RHL, then we say then limit exists. If limit is existing, I will get to know the value. What should have been the value at this particular point f of a? What would be the value of f of a when I put x is equal to a? Now this was the thing what you learnt in your 11th standard. The continuation of this is, what even I plug in x is equal to a also, if I get the same value 3 there at f of a, then we say it is a continuous function. So this is a discontinuous function. It is a discontinuous graph. Discontinuous function. Okay, so now what is continuous function? So what is the definition of continuous function? So we already saw that if LHL is equal to RHL, limit exists, and if this LHL is equal to RHL is equal to at that point f of a also, then we say it is a continuous function. Continuous function definition is very important for your 12th standard. Okay, so what is a continuous function? Continuous function is a function f of x as limit x tends towards a is said to be a continuous function if limit of f of x as x tends towards a. What does this a includes? It includes both LHL as well as RHL, a minus as well as a plus is equal to f of a. This is the definition of continuous function. So now for this year, for continuity and differentiability, one weightage is one question is compulsory for your pure question of limit and continuity is compulsory for your objective, that is in JEE or KVPY, but then this limit will be applicable for differential calculus, for integral calculus, for determinants, anywhere and everywhere where the functions come, they can apply limit and ask you to find out its determinant or its differentiation or its integration, anything as such. So this application of limit is very important, the concept understanding is very important. So now that we saw that when there is no break in the graph, it is called as what? Continuous function. We can go to its algebra. Even before getting into its algebra of the continuous functions, let us get into few problems where I can make you understand. So this is a continuous function. Continuous function y is equal to f of x. Okay. So the next we are getting to the problems. So you see in exercise 5.1, based on this continuity you have certain problems, and also when it comes to the product and addition subtraction of the functions, also we have the continuous function properties, theorems, and also for composition of functions. So slowly one after another we'll get into that. We'll go to the problems now, because just now we have understood a little thing about continuity. I will tell you what is the meaning of that. See, we have a very linear polynomial here, very simple one. The first question, they have given f of x is equal to 5x minus 3, and they want us to prove that it is continuous at x equal to 0, at x equal to minus 3, and at x equal to 5. Whenever you see these kind of linear polynomial functions, please understand that they are always continuous functions at all points. So let us start with at x equal to 0. I'll start at x equal to 0. How do you do? So the first part is limit of f of x. I'll apply limit of f of x as x tends to what number? As x tends to 0 is equal to what? It is choosing the function. Your first job in limits lesson is to choose the function when it is x is tending towards 0. If it is 0 minus or 0 plus, then it is left hand limit and right hand limit. Now as such we do not know any left hand or right hand, but instead we have only the function. So I'll just apply as x tends to 0 and choose the function which is given to be 5x minus 3. 5x minus 3 as x tends to 0. Further, in the further problems they will tell you when it is 0 minus what function to choose, when it is 0 plus which function to choose, they are going to give you the options. As of now we don't have any, we have only one function. I have replaced f of x by 5x minus 3, and now what is my job? My job is to put the tendency value into x. I'll plug in. So since I am applying the limits, there is no need of putting limit now. I am applying the limit, that is as x tends to 0. Yeah, 5 into 0 minus 3 is equal to minus 3. Okay, next second one, f of x is equal to, the second sub question, I have f of x, I made a mistake. You know what, first I applied limit, next what I'll do, I will do f of 0, that is the function at exactly x equal to 0. I will go directly to the function. I will plug in x is equal to 0 minus 3 and I got again 0 minus 3 is equal to minus 3. This is the definition of continuity. That is, therefore, limit of f of x when x is tending towards 0 is exactly equal to f of 0 also. So, this implies the function is f of x is continuous at x equal to 0. So, there are two parts in proving that yes, it is continuous. Once you will apply limit and once you will do without limit. See, this is without limit and this is with limit, and both are equal to the same number, therefore it is continuous. So, when it comes to linear functions, it is very easy. And then we will come to the second sub question of that. The second sub question tells at x equal to minus 3. Again the first part, first I will apply limit and then I will do without limit. So, see, limit of f of x as x tends to what number? Minus 3. Again choose the function, it is the same function, f of x is equal to 5x minus 3, and now plug in x is equal to minus 3. So, we got 5 into minus 3 which is equal to minus 18. Minus 15 minus 3 is minus 18. Then I will plug in directly x is equal to minus 3, and that is called as f of minus 3. F of minus 3 is, go to the function f, just like your functions chapter, go to the functions function and directly put x is equal to minus 3. So, I will come here 5 into minus 3 which is equal to minus 18. So, again we will say, since limit of f of x as x is tending towards minus 3 is equal to f of minus 3 is equal to minus 18, both are equal, we say this implies the function is continuous at x equal to minus 3. Okay, now after this, now we go to at x equal to 5, I will leave it for you children. So, you have the third part here, where you have the third part, you have x is equal to 5, you do it by yourself. Alright, now I am going to the second question, which is the same type, limit as x tends to 3 we should do, because they have given at x equal to what? In the second question they have given at x equal to 3. Okay, examine the continuity. Now I would like to do in a little different way. See, examine the continuity, they are telling function of f of x 2x square. There it was proved that, so I did LHL and RHL separately, I told they are equal. Now what we will do, see they are talking about continuity, right? For continuous function, for continuity at x equal to 3, we have to write like this, limit of f of x as x tends to 3 should be exactly equal to f of 3. See, this is the definition of continuity. We have come to the core of this, core part of this concept. Whenever they say continuous function, you are going to start with this definition and plugging in whatever the point at the point number, whatever they say. So, they are telling at x equal to 3. So, we have to write limit of f of x as x tends to 3 should be exactly equal to f of 3. So, directly I am using LHL and RHL. This will be the easiest way of doing. So, let us do now this, you have limit as x tends to 3, your f of x is what? Your f of x is 2x square minus 1 is equal to f of 3 means what? Go to the function and plug in x is equal to 3. You have 2x square, so 2 into 3 square minus 1. Again here what should I do? I should plug in x is equal to 3. So, I have 2 into 3 square minus 1 is equal to 2 into 3 square minus 1, which are the same. So, 3 square is 9, 9 2s are 18, 18 minus 1 is, we have got 17 is equal to 17. So, we will say since limit of f of x as x tends to 3 is equal to f of 3, this implies f of x is continuous at x equal to 3. Okay, now that was the easiest way of proving continuity, and based on this continuity itself, it is a compulsory question in PU board examination also, and these kind of questions where you have to find out k value with continuity, will be occurring very frequently in board examination of both 12th CBSE as well as the second PU board of Karnataka board. And now let us go to the further problems. So you have examined the following functions for continuity, you have like this. So I have taken third, there are ABC questions, I have taken B, f of x is equal to 1 by x minus 5, and they want us to examine the continuity of this function. And beside this you also have x not equal to 5. So when they have given x is not equal to 5, we'll other than 5, so let x be equal to c. Okay, we'll not take 5, any other number I'll take. Then I'll start like this: limit of f of x as x tends to c is equal to limit of f of x, limit as x tends to c of f of x I'll choose as 1 by x minus 5, and I'll plug in the limit, that will be 1 by c minus 5 is equal to some number p. Then I'll say f of c also would be 1 by c minus 5 is equal to p. So since limit of f of x as x tends to c is equal to f of c, this implies f of x is continuous function, is continuous at any point x equal to c. See, when I put x is equal to 5, this is going to become not defined. 1 by 0 will become not defined. Except that point, everything else. Had they not given x is not equal to 5, I would have written at the point x is equal to 5, this is going to become not defined. Therefore, it is discontinuous function. We had mentioned that. But then now they themselves have given that x is not equal to 5. Therefore, this function is continuous at x equal to any number c other than 5. So it's continuous at x equal to any number c, comma x not equal to 5. Similarly, when I go to question number C, here you have x plus 5 f of x, and for this also they would have given a condition that x is not equal to minus 5. See, for this question also they would have given a condition, they have given. So now I'll get into the next question, that is they have given f of x is equal to x square minus 25 divided by x plus 5. So we'll start like this: limit of f of x as x tends to, say, any number. If I put minus 5, it's going to become 0 in the denominator, and for this they have given x is not equal to minus 5. Again I'll say some number c as x tends to c will be equal to c square minus 25 divided by c minus of minus 5. Can I write like this? So it will be c square minus 25 divided by c minus of this plus I have written as minus of minus 5, and this 25 I can write 5 square. Okay, I made a mistake here, I forgot to write the limits. So this is limit as x tends to c of, and this is equal to limit as x tends to c. Have you seen this form? 25 I'll write as 5 square. Your c square minus 5 square divided by c minus of minus 5. Okay, so now you see that this 5 square can also be written as minus of minus 5, and then it is in the form of x square minus a square divided by x minus of minus a. Okay, so whatever, some number we are getting here, because I thought I'll use the formula x power n minus a power n divided by x minus a will be equal to n into a to the power of n minus 1. Can we use this? Because they are telling I am not supposed to use minus 5. I can't write this as minus 5 the whole square. I have only split this. So instead I can keep it as minus 5 plus 5 itself. I cannot use it because this number and this number are the same. Okay, whatever. This is equal to some number p. When I plug in x is equal to, I have plugged in x is equal to c already. I should not have written limit here. C minus of, okay. So limit as x tends to c. I have plugged in c here. Here let me write this as x square. This is x square, this is x minus of minus 5 I have written. But then there is no use of writing minus of minus. If I plugged in x is equal to c, which will fetch you some number p. And then when I say f of c also, this is going to be c square minus 25 divided by c plus 5, and it will be as good as this one, which is equal to some p. So LHS is equal to RHS. This implies f of x is continuous at x equal to c, some number c other than minus 5, and so let me mention x is not equal to minus 5. Okay, and then now we can come to a conclusion that all the polynomials, whether it is a fraction or it is a linear polynomial, you will always get this is f of x divided by g of x form, polynomial divided by polynomial, and it is entirely another polynomial. So all the polynomials will be continuous functions except for some restriction when you have divided by g of x. Okay, so there's a note point now. All polynomials are continuous functions. Continuous functions at all points. It is never discontinuous. We always get a straight line or a curve or something, but we always get a discontinuous curve. So all the polynomials will be continuous functions at all points except for when there is a fraction like this. So if there is a if f of x divided by g of x, then g of x should not be equal to 0. Except for this condition, the rest all times that the function is going to be continuous if they are polynomials. Okay, so now we are coming to the point to find out the points of discontinuity where f is defined by. And now in this you see all this time we used to see that in the previous questions we saw that there was only one function given to us. See, now they have told us that when x is less than or equal to 2 I should choose this function, and when x is greater than 2 I should choose this function. So your first job is to find out the function at that particular point, take that function and then continue. So now I am coming to question number 6, and I have taken certain number of questions from your exercise, children. See, after 6 I have gone for 10, 11, 12, which I feel okay, they are all important. So there are certain questions with modulus. I shall be discussing that once this concept is very clear for you. So now I'll go to f of x, that is f of x is equal to 2x plus 3 if x is less than or equal to 2, and 2x minus 3 if x is greater than 2. See, there are three options given to you: when x is greater than 2, when x is equal to 2, and when x is less than 2. So LHL, left hand limit, right hand limit, and at the point, all the 3 points have to be discussed for it to be a continuous function. And if it is not continuous function, we will get one of them as unequal to the rest. So let us see. So we will start with for continuity. For continuity at x equal to 2. Please run along with me. Every time for continuity, we are coming to, again I am telling you, to the core part of this chapter. I mean, for this concept, this limit and continuity, every time for the continuous function, when they mention the question, we are going to write the definition, all the three parts together at the time, and simultaneously we will run with all the three. So let us see, for continuity at x equal to 2, I need to write limit of f of x as x tends to 2 minus means less than 2 is equal to f of 2, it is exactly at that point, is equal to limit of f of x as x tends to 2 plus. Okay, so 2 minus 2 plus, and at the point, left hand limit, right hand limit, and at the point. So now let us go limit as x tends to 2 minus means less than 2. Where do you have less than 2? You have less than 2 here, x less than 2. For that I should choose a function 2x plus 3 and plug in for the place of f of x. So I will say 2x plus 3 here is equal to f of 2 equal to 2. So for both these together we are finished here. and then for greater than 2, for 2 plus means greater than 2, for greater than 2 you have the function given as 2x minus 3. So I'll plug it in this place. So you have limit as x tends to 2 plus f of x means 2x minus 3. Okay, now I'll plug in x is equal to 2. So it is 2 into 2 plus 3 is equal to 2 into 2 minus 3. Are they equal? 4 plus 3 is not equal to 4 minus 3. That is 7 is not equal to 1, implies left hand limit is not equal to right hand limit. Therefore, the function is not continuous. Function is not continuous. If it is not continuous, at what point is not continuous? It's not continuous at x equal to 2. So, point of discontinuity is equal to is x is equal to 2. At x equal to 2 it is discontinuous. Okay. So exactly like this we are going to do the rest of the 3 problems, children. And I thought by the time you finish your 2 or 3 problems you will get used to this method. And then we can think about this greatest integer or modulus function, etc. So let's become familiar with this. We have question number 10. Again we say for continuity. We'll discuss the continuity at what point. We always choose the point, the number whatever they have discussed about. Here they are discussing about 1. So I'll take at x equal to 1. For continuity at x equal to 1, we write limit of f of x as x tends to 1 minus is equal to f of 1 is equal to limit of f of x as x tends to 1 plus. So then again we will come back and see for greater than, for lesser than is here. They have chosen the, we have to choose the function what they have given for this as x square plus 1. For greater than and equal to they have given x plus 1. So for greater than I have written here and equal to they have given limit as x tends to 1, greater than 1 they have given x plus 1. I shall plug in the place of f of x as x plus 1. Next I'll come this side, limit when x is less than 1, that is 1 minus, they have given x square plus 1. So I'll write x square plus 1 in the place of f of x and then plug in x is equal to 1 minus the left hand limit, x is equal to 1. Here also I'll put x is equal to 1. So you got 1 square plus 1 is equal to 1 plus 1, 2 is equal to 2, LHL is equal to RHL, and this in turn implies f of x is continuous at x equal to 1. Okay. So f of x, this function was continuous, this function was discontinuous, this function was continuous. Now children, how can you do it directly orally? So we see that we are writing all the reasons, then plugging in the functions, and we are plugging in the same number whatever they have given for, right? So if you are supposed to do objectives, how are you going to do? Directly let us find out. See, I'll plug in x is equal to 2 here. 2 cube 8 minus 3 is 5. So for this LHL has become equal to 5. Okay, RHL, when x is greater than 2, I have x square plus 1, I will plug in x is equal to 2 here. When I plug in x is equal to 2, again 4, 2 2s are 4, 4 plus 1, 5, RHL also is 5. So this function is continuous. There is no point of discontinuity at all. We forgot to write that point in the previous one. Let's come back here. F of x is continuous at x equal to 1. Therefore, no point of discontinuity. No point of discontinuity exists for this particular function, because the crucial point where I have to discuss is 1, because everything is 1 in this question, right? 1 1. So at the point 1 is what is we have to think about. Other than that, you put for this linear polynomial, you put 2 3 4 5 or minus 2 minus 3 minus 4, anything, you will always get the same number over here in these two. So at this point x is equal to 1, it was continuous for us. So here if you plug in x is equal to see at x equal to 5 here, sorry, at x equal to 2, we are getting LHL as well as RHL the same number. So it is continuous at x equal to 2, and therefore there is no point of discontinuity other than, oh yeah, I think I made a mistake when I told you that when x is less than or greater than 1, here we are discussing exactly at the point 1, here we are discussing exactly at the point 2, only when it is linear polynomial. And this linear polynomial, here I have x and here I have x square. Suppose I take x is equal to 2, 2 plus 1 would be 3 and 2 square would be 4 plus 1 5. So let us discuss exactly at the referred point. If it is a linear polynomial like this, 2x plus 3 or 2x minus 3, then we will single polynomial, then it will be continuous at all the points. But when we have separate functions, we are going to have different values at different points. So here I hope I am not confusing you. I will tell you once again. Suppose you have f of x is equal to 2x minus 3, only one function we are discussing. This particular function will be continuous at all the points. When we have breakage of the functions, the graph is curvy for some things and straight line for some at some points, then see your function may be like this. It may be like this, then it may be like this, and then it may be like this. So for this it is different, for this it is different, for this it is different. So this may be x is equal to 2, this may be x is equal to 3, this may be x is equal to 4. So from different range, x less than, so I may say 3 less than, 3 greater than for different functions. When it is 3 less than, it is this, when it is 3 greater than, I will be taking this, etc. So when there is breakage of the functions, then we have to discuss exactly at that particular point. Okay, coming back here, we saw that there is no point of discontinuity here when we discuss exactly when x is around 1, 1 minus and 1 plus, it is going to be the continuous function, this particular function, that is when x is greater than or equal to 1 and x less than 1. Similarly, when I come here for question number 11, both are fetching us 5. Let us check out for the next question. Next question, this is x less than or equal to 1, greater than 1. So we are discussing at x is equal to 1, in and around 1, okay, without reaching the other number with epsilon values. When I plug in x is equal to 1 here, I am getting 1 minus 1 0. When I plug in here, I am getting 1 square which is equal to 1. The LHL is not equal to RHS, therefore at x equal to 1, this function is discontinuous. This is continuous, but this is discontinuous. This is discontinuous because LHL is not equal to RHL. This is LHL, left hand limit, this is RHL, right hand limit, they are not equal. So at x equal to 1, in and around 1, it is discontinuous function. Okay, so now coming back to the theory of the theoretical part of that. So when you have to orally find out, it is like this. Even when we come to differentiability also, just like that, looking at the function for objective functions, when you have options, 4 or 3 or 4 options, then we can directly differentiate and find out whether they are differentiable or not. So that is a quick way of finding out whether it is continuous or differentiable at that particular point in the questions. Now coming to the theory part, it will be giving you 2 marks or 3 marks, so you need to write all the theory. So I'll come to question number 11. Question number 11, and I shall discuss at the point x equal to 2. So I'll say at x equal to 2, for continuity, limit of f of x as x tends to say 2 minus is equal to f of 2 is equal to limit of f of x as x tends to 2 plus. So this will be 2 minus, how have they given, let us see, 2 minus and at equal to, they have given x cube minus 3. So limit as x tends to 2 minus, this will be x cube minus 3 is equal to, these together they have given. Then limit as x tends to 2 plus, for greater than 2 they have given x square plus 1. X square plus 1. So I'll plug in x is equal to 2. 2 cube is 8 minus 3 is equal to, here 2 square plus 1. This is 2 cube. So this is 8 minus 3 is 5. 4 plus 1 is 5. LHL is equal to RHL. implies f of x is continuous at the discussed point x is equal to 2. Therefore, there is no point of discontinuity. Okay, there is no point of discontinuity. Only because we have to answer to the point, we are writing this no point of discontinuity. Otherwise, once it is for the continuous function, we are fine with that. Now we go to question number 12. Question number 12, I suppose you can do it by yourself. Then I'll finish it. And we say at x equal to 1, that is question number 12. And for continuity, limit of f of x as x tends to 1 minus is equal to f of 1 is equal to limit of f of x as x tends to 1 plus 1 minus, I'll say limit as x tends to 1 minus, I have to take x power 10 minus 1 is equal to limit as x tends to 1 of x square. So this will be 1 minus 1 and this will be 1 square. 0 is not equal to 1. So implies LHL is not equal to RHL, and that in turn implies function is discontinuous, or it is not continuous, because there are three kinds of discontinuity are there which is not there in your syllabus. So we say function is not continuous, and not continuous at what? At x equal to 1. Alright, so this was about the continuous and the continuity, and later on we have few more questions about finding out k value, and we'll go to one more function where you have 3 options, and again here I want you to orally finish off the problem, and then I want you to orally just finish up the problem first. See, it is discussed about at what point, you see, it is discussed at minus 1 as well as 1. So I need to discuss about at the point x equal to minus 1, at the point x equal to 1. Where is it, whether it is discontinuous or continuous. See, we'll finish up orally first. I'll take minus 1 for less than and also equal to for minus 1. They have given minus 2. There is nothing to solve at all. They have already given the value as minus 2. And for x greater than minus 1 less than x is as good as x is greater than minus 1. When x is greater than minus 1, they have given 2x, wherein I have to plug in x as equal to what? Minus 1. Minus 2 and minus 2, they are equal. So the function, the given function is continuous at x equal to minus 1, that is in and around of minus 1, it is a continuous graph. Okay, and now I am going to 1. See, when I am having 1 at x equal to plus 1, they have given 2x, that is less than and equal to at 1. I will plug in x is equal to 1, I have got 2. When x is greater than 1, they have given the number itself, the real value itself as 2. Again, it is continuous at x equal to 1 also. So this function is continuous both as well as at equal to minus 1 and x equal to 1. In and around of minus 1 and in and around of 1, it is continuous function. So now when you want to write at x equal to minus 1, one side will write, break up your page and do directly at x equal to minus 1 at x equal to 1. And we say for continuity, limit of f of x as x tends to minus 1 minus is equal to f of minus 1 is equal to limit of f of x as x tends to minus 1 plus. Similarly, here I shall write limit of f of x as x tends to 1 minus is equal to f of 1 is equal to limit of f of x as x tends to 1 plus. So at 1 minus, limit as x tends to 1 minus, which is the function I have to choose. For 1 minus, for less than and equal to, together they have given it as only 2, no, minus 2. and when x is minus 1 plus for greater than minus 1, then it is 2x. So here I should write limit as x tends to minus 1 plus it is 2 into x. I plug in x is equal to minus 1 there. Here I have got minus 2 and this is 2 into minus 1. LHL is equal to RHL. Therefore, function is continuous at x equal to minus 1. We have discussed at x equal to minus 1 for x equal to 1. So, limit as x tends to 1 minus for lesser than or equal to they have given 2x is equal to these two together is over. Next, I'll say limit as x tends to 1 plus f of x is exactly 2. So, 2 into 1 is equal to 2. Once again, we say LHL is equal to RHL. This implies f of x is continuous at x equal to 2. Okay. So, at x equal to 2, I am sorry, at x equal to 1. So, we see that the given function at two different points, they are equal. So, now my point in this particular question why I took was, whatever the points they have discussed at, in and around that point, you have to find out for all the, at all the given points, minus 1, 1, sometimes they'll say 1, 2, 3, anything. So, because there is one particular question like that, in question number 14, they have discussed about, see they have given one option as 0 less than or equal to x less than or equal to 1, and in the next option they have given minus 1 less than x less than 3, and the other one they have given 3 less than or equal to x less than or equal to 10. So, which are all the points that you are going to discuss about? There are so many numbers here. You have 0, you have 1, you have minus 1, you have 3 and you have 10. Okay, 0 less than or equal to 1 or minus 1, let me check. This is not minus 1, this is plus 1 because they cannot give in between. I was wondering. So, and now you know for this, they have given this is 3, this is 4, this is 5. F of x is equal to, yeah, this is the function what they have given us. So, where all you are going to discuss? Say, I cannot discuss at x equal to 0. I cannot discuss at x equal to 10. Why? Because they have not mentioned for the in and around, whatever I say, whenever I say in and around, it is left hand and right hand. We don't know what is happening behind 0 or after 0. We don't know what is happening for after 10. What is happening? I do not know. After 0, I have something to think about, but after 10, I don't have. Similarly, before 0, I don't know what is happening. So, I cannot discuss about its limit. So, first of all, what is the meaning of this limit? Limit means you are discussing about certain range of values before that and after that value whatever they are given. So, here you have x is equal to 0 where you don't know anything about behind 0. Here they have given the end point 10, you don't know what is happening after 10. That is 10.01, 10.02, 10.0023 something. We don't know what is happening. So, I don't know whether limit is applicable or not. So, we will be discussing exactly at 1 because I know all the 3. I have x less than, I have x equal to, I have x greater than. So, when x is less than or equal to 1, when x is less than or equal to 1, the value is 3. When x is greater than 1, the value is 4. LHL is not equal to RHL. So, this will tell, implies LHL is not equal to RHL at x equal to what? At x equal to 1. So, at x equal to 1, it is going to be discontinuous. So, next I am going to discuss about less than 3, and then here x is greater than 3, x is equal to, when x is less than 3, it is going to be 4, when x is greater than or equal to 3, it is going to be 5. So, LHL is not equal to RHL. So, it is not equal, it is not continuous, it is not continuous at x equal to 5 also. So, this is a function where it is the points of discontinuity. What are the points of discontinuity? The points of discontinuity are 1 and 3. We are not discussing about 0 and 10 because it is not fully explained, or it has to be defined properly what is left hand, what is right hand, then only I can discuss about the limit. And when they are equal, then only I say limit exists. When it is LHL is equal to RHL and also at the point, then I say it is continuous. So, there are these are the 3 things what you should understand. When it is not at all defined, when it is defined and when it is limit is existing, and when it is defined, limit is existing, whether it is continuous or not. So these are three parts what we have learned till now. Now with that we'll stop here, and in the next session, that is next immediate session, we will see how to find out the value of the unknown things when they have already given the function is continuous. And children, please go through, sit and read the theory of the limit of the functions and continuity of the function what you have in your text. And I shall briefly explain about this modulus function, how to break the modulus function whenever you have modulus, and continue to find out what is the value of k whenever they give the continuity definition. And finding out this k value, the unknown value when they have given the function is continuous, is of the utmost important concept in this particular concept, that is the inner concept. Okay, that's very important, and that we will discuss in the next class. Thank you.